integers, fractions, decimals, and percentages. So we know what are integers. Integers are whole numbers. Okay, they are positive whole numbers and negative whole numbers. Integers either positive integers or negative integers. Okay, we studied this in chapter 1 where we are looking at numbers. We studied integers. The fractions are a part of a whole, something that is not full, but just a part of a whole. Okay, decimal is when we divide the numerator of a fraction by the denominator, we get decimal. Percentages is multiplying whatever we have, either the fraction or the decimal multiplying by 100, we get percentages. Okay, so when we say fraction, it's just a part of a whole, meaning you're not considering the whole thing, you're looking at a portion of the whole thing. So which means you either have something over something. Let's say we say 1 all over 2, 1 all over 3, 1 all over 6. These are fractions because you are saying 1 out of 2 things. You take 1 out of 2. This one means take 1 out of 3. This one means 1 over 6. So if I have a box like this, if I divide it to 2, if I divide this into 2, and I shade one of it, so the fraction will be 1 out of 2. 1 all over 2, it means 1 all over 2, meaning you have 2 things, you've taken 1 out of 6. If you make it 3, it becomes 1 all over 3, and so on and so forth. Okay, if you have 3 over 10, means if you have 10 small boxes, you've taken 3 out of those 10, or you shaded 3 out of 10. So that's what we mean by fraction. We have different types of fraction. Every fraction, we have a numerator, the one on the top, and we have a denominator, the one on the bottom. So the numerator is a part of a fraction that is on the top, and the denominator is the bottom one, the one on the bottom, the one that consists of the whole of everything that you've divided into. So when we say we have 3 types of fraction, we have a proper fraction. We have number 1, we have a proper fraction. Number 2, we have improper fraction, and number 3, we have a mixed number or mixed fraction. Number 3, we have mixed number or mixed fraction. We have number 1 proper. Here's number 1 proper fraction, and this one is number 2 improper fraction, and number 3 mixed number. Now, what's a proper fraction? A proper fraction is a type of fraction where the numerator is smaller than the denominator. You take a look at this 3 over 4. The numerator is always smaller than the denominator. You take a look at this 1 all over 2. The numerator is smaller than the denominator. Numerator smaller than the denominator. Anytime you have a numerator smaller than the denominator, we call it a proper fraction. Now, improper fraction, as the name implies, is improper, meaning the one on top, which is the numerator, is bigger than the denominator, like 9 over 2, like this 9 over 2. So when you have the numerator bigger than the denominator, we call it improper fraction. Now, let's move on because these are revisions for us. Mixed numbers are improper fraction. Another name we call it is a vulgar fraction. You can call it a vulgar fraction. That's for improper fraction because it's vulgar. The numerator is way bigger than the denominator. Okay, so it's vulgar fraction. A mixed number or mixed fraction is a type of fractions that involve whole numbers and a proper fraction. For example, 4 whole number 1 over 5. 4 whole number 1 over 5 is an example of a mixed number or mixed fraction. Then another thing we can do in fractions, we can simplify fractions and we can solve fractions. Work example. For example, say 1 over 5 of 35. Off in fraction means multiplication. Off means multiplication. So when we say 1 all over 5, 1 all over 5 of 35, it means off means multiply. You say multiply by 35. So whenever we have this, we don't even need to use the calculator. But we can use calculator, but this is simple enough not to use calculator. It's simply saying 1 times 35 is 35, 35 over 5. It simply means 35 over 5. So what you do is say, how many times can 35 go into 5 go into 35? 5 divided by 5, you get 1. 35 divided by 5, you don't need a calculator. 35 divided by 5, you get 7. So our answer is 7. When you say 1 all over 5 of 35 is 7, what it means is that if you divide something into 35 places, if you want to share them into 5, each person will get 7. Each person will get 7. If you divide something into 35 places, if you want to share them into 5 places, or there are 5 people to give equal number to, each person will get 7. That's what it means, okay? So if we say 3 over 5 of 35, what it means is to just simply to say 3 over 5 times 35. We do the same thing we did just now. We say the denominator divide by the numerator, or the numerator divided, this numerator will be divided by this denominator. 5 here 1, you get 1. 5 into this, you get 7. 7 times 3, you get 21. So our answer will be 21 in this regard, okay? Because you break this one down, then you multiply by this numerator, you get 21. So these are in paper 2 in Cambridge IGCSE. They put some small fractions. So here are some questions for you to try. 3 over 4. Okay, we do one of it before we move on. Okay. We say 3 over, let's pick any one. 3 over 4 over 5 times 20. Okay, or 4 over 9 times 45. 4 over 9, this one. Let's do this one quickly. 4 over 9 times 45. So what you have here is just to simply multiply. 4 over 9 times 45, you say, how many times 9 can go into 45? 9 divided by 9, we get 1. 45 divided by 9, you get 5. You don't need a calculator for these simple things. You need your multiplication table. You need to understand your multiplication table. Then 4 times, this 4 in the numerator, you now multiply by this. 4 times 5, you get 20. So our answer will be 20. 4 over 9 of this is 20. So this is what you do. You simplify a lot of problems. Let's move on because we have to move fast. These are pure revisions for most of the students. Now let's go to changing a number to improper fraction. Let's take a look at changing a number to improper fraction. Okay? So in a mixed number, changing a mixed number to improper fraction. In a fraction, you can change a mixed number to improper fraction. You can change improper fraction to mixed number. Now let's start with changing mixed number like 3 whole number 5 over 8 to improper fraction. What we do is to simply say, if you say 3 whole number 5 over 8, you want to change it to improper fraction. What do we do? You take this denominator of this to multiply this one. We use the denominator to multiply the whole number. So let's take the denominator to multiply the whole number, and then we add the numerator. So we go to do something like this. We say 3 times 8. We go to multiply the whole number with the denominator. So this will be 3 times 8. We're going to say 3 times 8. Okay. Then after we do that, you can put bracket in order to make not to be confused about the next step. Then we say plus 5. So here we go to multiply. Okay, this, and then we go to add this and this. We go to add whatever, we're going to say plus 5. Then we say plus 5 over the denominator. Plus 5 over the denominator. Okay? Over the denominator. So the next step to do, the denominator is 8, right? So you say 3 times 8. 3 times 8 is 24. 24 plus 5, you get 29. So this will lead us to 29 over 8. This will lead us to 29 over 8. So the only step you need to know in doing this, the only step is to remember that you multiply the denominator with the whole number. After that, you add the numerator. This times this 24 plus 5, you get 29 over 8 over the denominator. That's it. Same. Any number given to you, same. Now, what if another way, change the vulgar, the improper? Vulgar fraction means improper fraction. Changing the vulgar fraction or the improper fraction now to mixed number. Okay, the reverse case. Okay, now to change this one back to being something like this, what do we do? Okay, what we're going to do is that we say how many times 4 can go into 27? How many times 4 can go into 27? 4 can go into 4 times 7 is 28. So it's not up to 7. It's not up to 7 times. So 4 times 6 is 24. So we say 6. It can go there 6 times with some remainder. Because if you say 4 times 7, that would be 28, bigger than the number itself. So we cannot use 4 times 7. So we cannot write 7 as the whole number. So we say the lesser one. 4 times 6 is 24. You remember if you say 4 multiplied by 6, you get 24. 6, you go to get 24. 4 multiplied by 6, you get 24. You now find the difference between 24 and 27. That will be the remainder, 24 and 27. You know the number given to you is 27. So 27 multiplied by minus 24, you get 3. So you say 3 over the denominator. You say 3 over the remainder from 24. You say 3 over 4. How do you know that? This times this, if you want to change it back, 4 times 6, you get 24, plus 3, you get 27. You get 27 over 4. Okay? So how to do it again? One more time. You say how many times 4 can go into 27 with some remainder. Okay? It can go there 6 times. You write the 6 as 6 whole number. What remains? Because if you say 4 times 6, you get 24. What remains to get to 27? Is 3. You write the 3 as the numerator over the usual denominator. So that's how we do this. Is that okay? One way of doing this. This is one way of doing this. Is that okay? Okay, so let's move on. Here are some problems for you. You pause the video, you subscribe, you like, and then you solve some of this problem. We put this problem for you to try what we've talked about. Now let's move to decimals. Okay, decimals. Decimals are when we divide the numerator by the denominator. When we divide the numerator by the denominator. Okay? When we divide the numerator by the denominator, we get the decimal. Is that okay? So in decimal number, you know you've learned in primary school 100, tens, and units. And then you have the tenth, hundredth, thousandth. Okay, you have tenth, which means 1 over 10, hundredth, 1 over 100, thousandth, 1 over 1,000. So any number after the decimal point, the first number after the decimal point is tenth. The second number after the decimal point is hundredth. This is hundredth, meaning 7 over 100. Okay. The third number after the decimal point is thousandth. This means 8 over 1,000. So that's this number on the left before the decimal. They are the whole number. They're the usual unit, tens, and hundred. Is that okay? So this, if you want to change this one to fraction, this 3.27 means 3 plus, this 3 is 3 as a unit, plus 2 over 10. This 2 first is tenth, other tenth. This 2 over 10. This 7 is over 100. You say plus 7 over 100. Okay, this is how to put this one back. So which means if you're given this one, there is no number in the unit, it's 0. So the first one, other tenth, is 0 also. So the first one here is 3 over 100, 8 over 1,000 for this second one, if you're changing them back to fraction. Okay, so this is what you do with numbers. Write the following fraction as decimal. Okay, this is 4 plus 5 over 10. 5 over 10 is 0.1 over 2, right, which is 0.5. So this will be 4.5 if you change it to decimal. Okay, so this is what you do with this question. Now let's go to percentages. Let's move to percentages. Percentages is easy. If you're given a fraction, multiply it by 100. If you're given a decimal, multiply it by 100. It becomes a percentage. For example, 29, they've given a fraction 29 over 100. If you want to change to percentage, you say 29 over 100 times 29 over 100 times 100. Okay, they've already given you this fraction. They say change it to percentage. So you just multiply by 100, it becomes 29%. You know the symbol for percentage. Okay, so this 100 we cancel this 100, so we get 29%. So this will become 29%. What we have will become what? 29%. You put the sign of percentage or the symbol of percentage. Whenever you do percentage, you must put this symbol. That's to express something as percentage. Okay, this shows that the thing is in the percentage. You don't put this, then you will not express it as percentage. Now we can express other fraction that they are not over 100. You know this is over 100. Anywhere over 100 is very easy. It's just, if they give you 29 over 100, they say change to percentage, it means 29%. They give you 45 over 100, they say change it to percentage, it means 45%. What if they give you a fraction like 3 over 5, that is not over 100? They say change it to percentage. So 3 over 5, there are 2 ways or 3 ways of doing it. One of the ways is just to multiply it by 100. Okay? And then you get the percentage, which will give you around 60%. 5 go here, 5 here, 1. 5 go into this place, you get 20. So 20 times 3, you get 60%. This 20 times 3, you get 60%. This is one way of doing it. Okay? 60%. Another way of doing it is to change the numerator and the denominator make the denominator to be 100. Any number you use to multiply the denominator, you also use it to multiply the numerator. For example, another way of doing it, if you're given 3 over 5, another way of doing it is to say, okay, this is my denominator, I want to make it 100. What number will I multiply with 5 to make it 100? That means 20. So I have to multiply 5 with 20 to make it 100. So I must multiply this place with also 20 with whatever I multiply the numerator. So if I multiply this one, it becomes what? 100. So I have 100 in the denominator. I have 100 in the denominator. Okay. Then I have what? 60 in the numerator. 60 over 100 is what? 60%. 60 over 100 is simply 60%. So this is another way of doing it. If you don't want to do it in the first way we did it, it's also 60%. Okay. So there are 2 or 3 ways of doing it. First, change the denominator to 100, and then you simplify. So here are other questions like 70 over 100 over 25. If If you want to change this one to percentage, you can just multiply the numerator and denominator by the same number. Here, we multiply by 4. You multiply 70 by 4, multiply 25 by 4. If you multiply 25 by 4, you're going to get 100, right? You're going to get 100. So 70 times 4, what do you get? If you multiply 70 by 4, what do you get? You get what? 68. So this is going to be 68%, because it will be 68 over 100. 68 over 100 times 100 will give us what? Will give us 68%. So for this question, it's going to be 68%. 70 over 25 is 68%. So same applies to all of this one. Okay, you can use any method you like to convert them. Now let's move on. Okay, because for Cambridge, you'll be given some questions. You may be asked to change some fraction to decimal, decimal to fraction, or to percentage. If you give 1 over 10, they say change it to decimal. This will be 0.1. This will be 0.1. 1 over 10 is 0.1 if you change it to decimal. Okay. Now, if you change to percentage, multiply by 100. 0.1 times 100, you move any decimal times 100. You move 100 has 2 zeros, so you move this one 2 times to be 10%. This will be 10%. If you change it to percentage, this will be 10%. Okay, if you change it to percentage. Now, if this is 30%. 30% in decimal will be 0.3. Will be 0.3. Will be 0.3. In decimal, it will be 0.3. In fraction will be 30 over 100, right? If you simplify to the lowest term, will be 3 over 10. Lowest term will be 3 over 10. So this one is 3 over 10. Okay, if you simplify to the lowest term. So this one is 0.2. You already know it's 2 over 10. 0.2, you know it's 2 over 10. If you change to percentage, you already know it's 20%. You already know this 20%. So these are, you fill this one up, and as a rule that helps you. Now let's go to the four rules: the addition, the subtraction, multiplication, division. They are all mathematical operations. So we need to know how to do this. Okay, how to do. So we just do one example. I think this is just a mere revision for most of us, right? It's just a mere revision. Now let's start with multiplication. So if you're giving 184 times 37, what do? So we put the multiplication sign here. We multiply by 37. So what do? You take this 7. These ones are also in Cambridge. You'll be surprised. In paper 2, they give question like this. So you say 7 times 4, 28, right? So we write 8, we carry 2. We write 8 down, we carry 2. So 7 times 8, 56, plus 2, 58. So we write another 8, this time we carry 5. 7 times 1, 7 plus 5. 7 plus 5, we get 12. So we write the 12 down. Because is the last digit, we're going to write the whole 12 down. We will not be able to carry anymore. So now we're done with using 7 to multiply 184. Now we want to use 3 to multiply 184. So you say 3 times 4. Since you are using 3, you're going to start writing the answer below 3. We're going to start writing the answer below 3. So you say 3 times 4, 12. I write 2 here. I carry 1. So 3 times this one, 3 times this, 24. 24, 3 times 8 is 24. Plus 1, you carry 25. So I write 5 here, I carry 2. 3 times 1, 3. Plus 2, you carry 5. Right? 5. So we are done with using 2. So the next is to add them together. The next is to add. Yes, you'll be surprised. Oh, so we did multiplication, we want to add. Yes. You use 7 to multiply 184. You use 3 to multiply 184. You add them together. Okay, so 8 plus 0. Yes, it's going to be 0 because empty, nothing. So if you like, you write 0. If you like, don't write 0. Just 8 plus whatever empty is 8. So we write the 8 here. Now 8 plus 2, 10. So I write 0. I carry 1. 2 plus 5, 7 plus 1, you carry 8. Then 1 plus 5, 6. So we get 6,808. So this will become our answer for multiplication. So I think this is a good one for us as an example for multiplication. Let's jump to division. So one example is enough for each of this one because it's just a revision class for most of you. Now let's say you are given 453. They say you should divide it by 6. 450. You should divide 453, not 56. 453. We should divide it by 6. So our long division, we put 6 here. We are dividing it by 6. Remember, this is 3. This is not, or we can even erase it. We can erase this one and rewrite it again. 453, so that we will not be confused later on. Okay? 453 divided by 6. So what do? You see how many times 6 can go into 45. 6 times 7 is 42. 6 times 7 is 4, so it can go several times. Okay, so you write 7 on top. You say 7 times 6, you get 42. You subtract. You say 42, and then you subtract. When you subtract, what do you get? 45 minus 42. 45 minus 42, you get 3, right? You get 3 left. Now that 3 that is left is smaller than 6. Smaller, so you bring this one down to join it. You bring this one to join it. It becomes 33. It becomes 33. So how many times can 33 divided by 6? 5, right? 5 times 6 is 30. So we say 5. So 5 times 6, we say 30. 30. Then we subtract again. You know, once you do the second phase, you subtract. You subtract again. So when you subtract, okay, I'm going to put it in decimal, even though they just did it, and okay, we're going to finish it up in decimal. When you subtract, you get 3. Now, 3 cannot be divided by 6 in this regard, so you add 0. When you add 0 to this place, you put a decimal point here. So you put a decimal point, and then you add 0 here. So you say 30 divided by 6, you get 5. 5 times 6, you get 30. So you see now when you subtract, you get 0. When you subtract, you get 0. No more number. That means you've reached the end. So our answer is 75.5. Our answer for this division is 75.5. So you can pause the video and go through it again how we did it. And I hope this is sufficient for you. I hope this is sufficient for you. Let's move on because we have a lot of things to do. There's another division which you can also explore. Here you say 71. How many times can 23 can go into it? 3 times. Okay, so you can try this long division and see how it works for you. Now let's go to mixed operation. We've done mixed operation in chapter 3, other bit mass. So we hope, but we're going to repeat it a little bit, even if it's 1 or 2 examples. Now, mixed operation means you follow bit mass or board mass. You follow what we call bit mass or board mass. Okay? If you say bit mass, B is the bracket. B is the bracket. B is the bracket. I is the indices or power. D is division. M is multiplication. A is addition. And S is subtraction. So we're going to follow this order. When you give you mathematical iteration, you're going to do the based on what is, except there's a bracket. You solve the bracket first. This one, there's no bracket. There's no power. There is no indices. There's no division. There's no division, but there's multiplication. So it starts from here. Since the multiplication, it starts from multiplication, so we're going to do the multiplication first. We're going to do the multiplication first for this question. So let's try question A. Okay, we're going to do the multiplication first. So we say 3 plus 7, 3 plus 7 times 2 times 2 minus 4. So what we're going to do, we're going to do the multiplication first. We're going to do the multiplication first. We're going to do the multiplication first. This one. We're going to multiply first. So we get 7 times 2, we get 14. 7 times 2, we get 14. Then there's minus here. There's plus on the left. Say plus 3. So the next thing in bit mass is what? The next thing is addition. So you do the addition next. So we do the next one, we do the addition. Okay, after you finish the addition before you do the subtraction, right? So the next phase is to do the addition. We add this to this, we get 17, right? We get 17. Then we say 17 minus 4 17 minus 4, our answer will be 13. Our answer will become 13. So this is how you do the order of operation, the 4 rules, what we call the 4 rules. Okay? This is how we do the order of operation for the 4 rules. But however, if there's a bracket, we're going to treat the bracket first. Now, in this example B, they put a bracket between 3 and 7. Now you're going to do the bracket. 3 plus 7 is 10. So let's do the B. For the B, 3 plus 7 is 10. So you say 10, you do 10 here, you write 10 here. Before you talk about the multiplication now follows. Because there is no division, you say multiply by 2. So 10 times 2, before you minus your 4. 10 times 2, you get 20. 20 minus 4, you get 16. So you can see you're going to get different answers because the bracket has been put in a different position. The bracket has been introduced into the question. So you're not getting 13 as in the case of A, you get 16. So this is how we do big maths. There are questions for you to try out. Now let's move to the next one, which is called calculation with fraction. Let's take a look at this. This equivalent fraction, which means 1 over 2, because we divided this whole rectangle into 2 equal parts. So one portion of it, or the colored one, is 1 over 2. But the same size, if we now break it to, like we draw a line, we now have 4. 1, 2, 3, 4. So the colored one is 2 over 4. So they are equivalent. 2 over 4 and 1 over 2, they are equivalent. Equivalent fraction is, if you simplify them, you still get to the lowest form, you still get the original fraction. That's the meaning of equivalent fraction. Now, 2 over 4, if you simplify 2 over 4, the colored one is 2 out of 4. 2 out of 4, the colored one, 2 out of 4. So if I divide, 2 divided by 2, I will get 1. 4 divided by 2, I will still get 2. So it will still return me back to 1 over 2. Such fractions are called equivalent fraction. A fraction where you can, when you simplify or break it down to the simplest form, you get the original fraction. It's called the equivalent fraction. It's called equivalent fraction. Is that okay? So this one is 4 over 8. By drawing more lines, you have 4 colored over 8 in total. So 4 over 8 is still same, is equivalent to 1 over 2 if you break it down. Because 4 divided by 4, you get 1. 8 divided by 4, you get 2. You still get 1 over 2 if you break it down to the lowest term or the simplest form. Okay? Now write 4 over 22 in the simplest form. If you're given 4 over 22, write it in the simplest form. You start to break it down with a prime number. For example, 2 can go into 4. 4 divided by 2, you get 2. 22 divided by 2, you get 11. So this one, you can no longer divide with the same number. So the simplest form, this will become 2 over 11. This will become what? It will give you 2 over 11. Is that okay in the simplest form? Now what if you're given 12 over 40? If you're given 12 over 40. 12 over 40, you look for the highest common factor that can go to the two numbers. The highest common factor. Okay? The HCF that can go into here. 6 cannot go into 40. 6 can go here. Okay? 4 can go here, 4 can go here. So if I say 12, the highest common factor I think will be 4. 12 divided by 4, divide both numerator and denominator by the same number, by the same factor, highest common factor. So you say 12 divided by 4 and 40 divided by 4. So 12 divided by 4 will give us 3. Will give us 3. This will give us 3. Let's change our color. This will give us 3 in the numerator. And in the denominator, 40 divided by 4 will give us 10. So this gives us 3 over 10 as the simplest form of this fraction. Okay? These ones are always in Cambridge. Put it in the simplest form and whatever. 5 over 10, 5 divided by 5, you get 1. 10 divided by 5, you get 2. So this one, in the simplest form, will be 1 all over 2. Is that okay? In this exercise, 1 all over 2. This will be 1 all over 2. So you always find 4 can go here into 16. 8 cannot go into 36, so 4 can go. 4 is the highest. 4 go here, we get 4 in the numerator. 4 go into 36, you get 9. This becomes 4 over 9. Okay? So this is how we do them. They're easy. This one, 25 can go. 25 go is the highest common factor between this one. So 25 go here, you get 3. You get 3 in the numerator. 25 go into 100, you get 4. This one becomes 3 over 4 in the simplest form. Okay? They are all easy. It's not a big deal. Here 9 can go. 9 go into numerator. 9 times 9 is 81. So 9 go here, we get 9. 9 go into 90, you get 10. So this one is the simpler form, you get 9 over 10. Okay, these are exercises that we are solving for you. Now let's go to the next thing, how to add the fractions, addition of fraction. Fraction is very easy to add if they have the same denominator. It's very easy if they have the same denominator. If fraction have the same denominator, it's easy to add. For example, we'll give you 3 over 11 plus 5 over 11. You give you 3 over 11 plus 5 over 11. So you know we can use the, in fraction, we can do the 4 operation. We can add, we can subtract, and we can divide, and we can multiply fractions. Okay, so now we are doing the addition of fraction. But once the denominator are same, it's very easy. You just add the numerator over the denominator. So you say 3 plus 5, you get 8, and then you just say 8 over 11. Your job is done. Okay? You just say 8 over 11, your job is done. Once the denominator is same, just add the numerator together. If they are not same, there's a way we make them same. For example, I'm going to solve an example where they are not same. For example, you have 1 all over 2, 1 all over 2 plus 1 all over 3. As easy as this, but the denominators are not same. So one of the things you can do is to take the denominator of this one to multiply the whole of this, and take the denominator of this one to multiply the whole of this. So if you're going to do that, if we're going to do that, so we have to multiply this one by 3, and we have to multiply this one by 2, because we use the denominator of this to multiply the whole of this. So we get new fraction. You say 3 times 1, you get 3 on top here, over 3 times 2, you get 6 over 6, plus 2 times 1, you get 2 here, over 2 times 3, you get 6. We've made the denominator to be same. We made it to be same. Once they are same now, you just add the numerator. 3 plus 2, you get 5 there over 6. You don't add the denominator since they are same. You just write it once. That's your answer. Okay, so it's easy. The same thing applies to multiplication, subtraction. The same thing applies. Okay, let's say you're giving mixed number. If you're giving mixed fraction, 5 whole number, 3 over 4. Let's do this one. 3 over 4. You change that to improper fraction, and then you carry out your job. Okay, minus 2 whole number, 5 over 8. If you give you this, what do? You change this one to improper fraction. You say 4 times 5, 20. 20 plus 3, you get 23 over 4. So we get 23 over 4. Right? We get 23 over 4. Now let's change the other one to improper fraction. 8 times 2, 16 plus 5. 16 plus 5 is 21, right? So we get 21 over 8. So in this case, we get 21. Now we notice something. This one is just half, this denominator is half of this. So instead of saying take this one to multiply the whole of this and this one, just say multiply the whole of this one by 2. You don't need to use the denominator of this to multiply this, and because this is half of this. So the next thing to just do when you have a fraction like this is simply to say multiply the whole of this by 2. That's it. Multiply the whole of this by 2. You don't need to do effect it here. So if I multiply this one by 2, this will be equal to 46. I'll have 46 over multiply this one by 2, I get 8, minus, you just write this one the way it is, 21 over 8. 21 over 8. So now you can see the denominator are same. Since the denominator are same, just subtract. Since it's subtraction, subtract the numerator. So you say 6 minus 1, you get 5. You get 5. And then 4 minus 2, you get 2. So I get 25 over 8. So I'll get 25 over 8. Right? You get 25 over 8. So you can change it to your mixed number. How many times 8 can go to 25? 3 times. So you write 3 whole number, remainder 1. Because 3 times 8 is 4, is 24. Remainder 1. So you say 1 over 8. So you can either leave it like this or you put it in the mixed number. That's it. Is that okay? So with this, you pause the video, like, subscribe, and share, and solve these questions. You pause the video and solve this question at this point. Solve all of them and move on. Don't say, oh, they're easy. Even if they're easy, solve them. Look at them here. Solve them. Okay? Solve them as a revision for you. As a revision. Now we go to multiplication and division of fraction. Now if you're given, we've done addition and subtraction of fractions. Now we go to multiplication and division. If you give it 3 over 4 times 2 over 3, this type, they're easy because you know why this type is easy for multiplication? The numerator and the denominator are same. They can simply cancel out. Okay, we cancel out numbers in multiplication, in fraction. So these 3 in the numerator can cancel out these 3. Okay, this most of the time you don't need calculator. You just see what can cancel when you are doing multiplication. Then this 2 divided by 2, you get 1. This 4, you also divide it by 2, you get 2. So which means we only have 1 times 1. Here is 1, here is 1. You know, right? When you divide. Say 1 times 1. Don't say 1 plus 1. It's not plus. 1 times 1 is 1. So in the numerator we have 1. In the denominator you say 2 times 1 is 2. So our answer will be 1 over 2. Like you have here. 1 over 2. Is that okay? So don't say, oh, 1 plus 1, 2. 2 plus 1, 3. No, that's not its multiplication. So if you give you this one, this type of multiplication, change to a proper fraction. 2 times 3, you get 6 plus 1, 7. You get 7 over 2 here. And then you say this times this, you get 28 plus 4, 32 over 7. So this 7 cancel this 7. We cancel this 7. Right? And then 2 here, 1. 2 go to 32, you get 16. Right? So your final answer will be 16 if you do calculation. If not, you end up saying 7 times 32, you get 224. 2 times 7, you get 40. You now divide big number by big number. So the easiest way is just to say 7 in the numerator, divide by 7 in the denominator. 2 here, go into this, okay? And then 2 go into 32. Now let's say that's what you do. That's what you do for this type, okay? That's what you do for this type. You break it down. 7 cancel 7. And then 2 here, 1, 2 into 32, 16. So your answer just becomes 16. You don't need to multiply them and get big numbers and start having a problem on how to divide big numbers. Is that okay? So that's that for multiplication. I think we look for one division problem. One division problem. 3 over 8. 3 over 8. Divide by 3 over 4. Divide by 3 over 4. Okay, in division, what we do is to change this one to multiplication and flip the right one. Flip this one, okay? So change this one to multiplication. So we say 3 over 8. This will become 3 over 8 times. We change this one to multiplication and flip this one. So the denominator becomes the numerator. So 4 will be on top now, not at the bottom. And 3 will be at the bottom. So once you do this, then you've changed the division to multiplication. This is how to change it to multiplication before we continue. Then you can now see that this 3 will cancel this 3. And then 4 divided by 4, I will get 1 here. And 8 divided by 4, I will get 2. So my answer will be 1 all over 2. My answer will be 1 all over 2. Is that okay? When you do this division, you get this 1 over 2. You get this 1 all over 2. Is that okay for this division? Similarly, that's what you do here. You change this to a proper fraction. 2 times 5, you get 11 plus 1. 2 times 5, you get 10, plus 1, you get 11 over 2, divide by 3 times 3, 9, plus 2, 11 over 3. So you change this one to multiplication by flipping this one. So this 11 will cancel this 11, we get 3 over 2 left as your answer. Is that okay? So we have given you exercise here. Pause the video, solve this exercise before you move on. We have a lot for you here. Pause this video at this point and solve all of these questions. Now let's go to changing a fraction to a decimal. I think we've done something like this, changing a fraction to a decimal. But let's just see to try and do one more. We've done something like this before. Let's do one more. For example, a simple fraction like 5 over 8. Let's change it to decimal. So if you want to change it to decimal, you write 5 here. The one you at the bottom, you bring it out, put it here. So how many times can 5 divide by this is 0 times, right? Because this one is bigger than this. So you put 0 here. And then you put a decimal point so that you can add 0 here. So that you can add 0 here. So it becomes 50 divided by 8 now after you put the decimal point. It becomes 50 divided by 8. 50 divided by 8, I think it's 6 because, yes, 6. Why? Because 6 times 8 is 48. You must be good with your multiplication in order to do division and multiplication. Okay, you must be good with your at least 1 to 12. You memorize it. Then you subtract, you get 2. You get 2. Because you already put decimal, you cannot put a second decimal. Just add 0 because 2 is less than 8. Just add 0 because you already had a decimal. So you say 20 divided by 8 How many times 8 can go to 20? 2 times, right? So you put 2 here. You put 2 here. You say 2 times 8, you get 16. You get 16. And then you subtract again. You get subtract. When you subtract, you get 4. You get 4. Now, you cannot put, though we add 0, you cannot put decimal again. Only one time we put decimal. So 40 divided by 8, you get 5. 5 times 8, you get 40. Now you get 40 and 40. When you subtract them, you go to get 0. That's the end of your journey. So you go to get 0, 0. Okay, so our answer becomes 0.625. This becomes our answer, 0.625. Okay, so this is how to change number to decimal. That's what they got here. The method they use here might confuse you from the textbook. Okay, I just do it in a way that it's not cumbersome. If they put in mixed number, you first change to a proper fraction before you do the division. Or you subtract these two, you just do this. This one will give you 3 over 0.6. So it becomes 2.6. Okay, quick way of doing this one. They give you mixed number, quick way. They give you 2 whole number, 3 over 5. Right? So no need to change it to a proper. Just write these 2 points. You already know 3 over 5 is what? 0.6. If you add 0.6 to this, you get 2.6. Okay? If you change 3 over 5, you get 0.6. If you add them, you get 2.6. So here you get 2.6 for this decimal. If you divide this, you get 2.6. Is that okay? So you have questions to practice and so on and so forth. Now let's go to recurring decimal. How do we do recurring decimal? This one is in IGCSE paper. You need to know how to do this. It's very, very important. Okay, this is the prime of this chapter. This is where the question comes from in the exam. So please pay very serious attention. Pay very serious attention here. Now it's a changing a recurring decimal to a fraction. Changing a recurring decimal to a fraction. Want to change it to fraction. Okay, recurring decimal, normally we just write 0 point. We just write 0 point. If it's 2 that is repeated, I'll just write 0.2. I put dot on top. This dot shows that 2 is repeating itself. Okay, so it means it's 0.2222. It keep repeating itself. So if you want to change it to a fraction, there's a way. Okay, there's a way to change this 0.2 to a fraction. So okay, so we can say let it to be equal to x, or let's go to changing this one to a fraction, 0.4444. So you say let x, let's say we say change, convert 0.4444. You know, we normally write 0.4 dot, change it to a fraction. We say change it to a fraction. What you do, you say let x equal to 0.4. How many times, the number of times you can write it before you put 4. It's up to you how many times you can write it. Okay, that's x. You can call it equation 1. And then multiply by 10. This is just 0.4. 4 is repeat. Only one digit number is repeating itself. If it's 2-digit number that is repeating itself, I multiply by 100. If it's 3-digit number, I multiply by 1,000. So I'll say if I multiply here by 10, both the left and right side, I'll have 10x here. 10x equal to, if we multiply this one by 10, this decimal will go here, become 4.44444. So it becomes 4.44444, like that. If you keep repeating itself. Okay, you can call this equation 2. So the next is subtract equation 1 from 2. Subtract 1 from 2. What I mean is that equation 2 will be on top, for example. Like you can rewrite them. You can say subtract equation 1 from 2. So I write equation 2 first. I say 10x, because it's bigger. Okay, you write the bigger one on top. You say 10x equals to 4.444, as many times as you can write it. 4. Then you call this one x equal to 0.44444. 4, 4. So then you say subtract. When you subtract, you get what? On the left, you get 9x, because 10x minus x is 9x, is equal to, if you subtract this, you get 4. Because this 4 we eliminate themselves. 4 minus 0 will be 4. So then you now make x the subject, because that's the fraction you want to make. Okay, it becomes 4 over 9. It becomes 4 divided by 9. Divide both sides by 9, that's the meaning. You get 4 over 9. Okay, so this is the fraction. If you convert this one to 0.444 to fraction, this, you get this 4 over 9. So that's the fraction. It means this 0. You say let x to be this. Remember, you say this 0.4 dot is x. So this 0.4 dot is equals, if you change it to fraction, is 4 over 9. It's 4 over 9. Now let's try another example 2, another one. 2 decimals repeated themselves. Let's say we say 0.668 dot on both of them. Dot on both of them is 68 will be repeated itself. So you can simply say let x equals to 0.6868. So let x equals to 0.68. Since there are dots on both of them, 68 will keep repeating itself. 68, and so on and so forth, right? And then, since two numbers are repeating themselves, I'm going to multiply. Two numbers are repeating themselves. I'll multiply both sides to get equation 2. This is equation 1. To get equation 2, I'm going to multiply both sides by 100. Because 100 has 2 zeros. So I'll have 100x. If I multiply this side by 100, I'll get 100x. Then I also multiply this one by 100. I'll get, if you multiply by 100, you shift this one twice. 100 has 2 zeros. So you get 68.68, like that. 68.6868, and so on and so forth, like that. So when you subtract equation 1 from 2, this is called equation 2. If you subtract equation 1 from 2, what do you get? You get, if like take this one away from this, you say 100 minus x, you get 99x. You get 99x. 100 minus x, 100x minus x, you get 99x. And this one minus this one, you get 68. You get 68 only. So we say this is equal to 68. So to get the fraction now is to make x the subject. Divide both sides by 99. So x will be equal to 68 over 99. X will be 68 over 99. Okay, so that's how to put this one in the fraction. That's how to put this one in fraction. Let's see, what of this one? Two numbers repeated themselves, but after 1 0. So there's a kind of it's still 2 digits that are repeating themselves, but after 1 0, there's something you're going to see. This type, let's just follow even without writing. I explain from here. So we say if two numbers are repeating themselves, but you write the first 0. You see, you say 0 point, let s equal to 0.0, then 31, like that. Because it's 2 digits that are repeating themselves, we also still go to multiply the left side and the right side by 100. So if you multiply the left by 100, you get 100x. If you multiply this one by 100, this is where you shift this one 1, 2 to be 3.1. See, to be 3.1, 3. So when you subtract this from this, you get 99. You get 99. If you say 100s minus x, you get 99x. But when you subtract 3.1, this is minus 0. This, you're going to get 3.1. Because we get 3.1, another decimal, because we get a decimal, we still go to multiply here by 10 and here by 10. So we still go to multiply this place by 10. We still go to multiply this place by 10 and also multiply this place by 10. So if we multiply this place by 10, you're going to get 990x. 990x. This one will no longer be a decimal, will be 31. So make it as a subject, you get 31 over 990. So it's different from multiplying by 1000. One could ask, why don't we multiply it by 1000 from the beginning? If you multiply it by 1000, you're not going to get 31 over 990. This one will be 999. Here will be 999. Okay, you're going to get something different. Okay, so, and moreover, it's 2 digits that are repeating themselves. So you have to multiply by 100 first. And then if there's still decimal, before you multiply by 10. Both sides by 10. Is that okay? Okay, so now that's that for that. Now what if they put a point here and a point here? What it means, the whole of these 3 digits will be repeating themselves. You see, they put a point here on top of 4. They did put on top of 0, but they put on top of. So they are telling you this whole 3 digits are repeating themselves. The first, the second, and the third. Even if they don't put dot here, dot here, dot here. Okay? It means the whole 3 digits are repeating themselves. So you say, let x equal to this one. You multiply here. Since 3 digits are repeating themselves, I'm going to multiply the left side and the right side by 1000. So 1000x equal to this number. When you subtract, you will still get a decimal point here. If you subtract, after multiplying with 1000, this number with 1000, you get 2040.640. When you subtract this one away from this, you will still get a decimal point. So I will still multiply here by 10. I also multiply here by 10. So I'll get 9990, and then I will get this. Then I will make this one the subject by saying x equal to this divided by this, and then we'll get this, and we simplify to the lowest term. We'll get this number. Okay. So with this, we've come to the end of today's class. I hope you understand. Pause the video and follow what we have said. Thank you very much for